Hello, my name is Dee. Assalamualaikum and a very good afternoon. Today I'm going to talk about interference test. What is it? Interference test is performed by creating a pressure interference in an observation well by operating the active well to a long duration production or injection rate. The test run to determine is reservoir connectivity, directional reservoir flow patterns, reservoir porosity, and nature and magnitude of an isotropic directional reservoir permeability.
Hello, my name is Hafiz. There are two cases for the test. The first one is case 1, which is active well is producing or injecting. Pressure behavior at the observation well is given by PWS is equal to P1HR plus M log T, and it is valid for the product of 0.002637 times K divided by porosity times viscosity times compressibility, and the square of radius or the value of the product is greater than 100. So when we plotting PWS versus T on a semi-log graph, it yields a straight line portion of slope M, which may be used to calculate permeability and porosity, where P1HR is obtained from the semi-log straight line at T equal to 1 HR. For example, we have plotted the PWS versus T on semi-log graph. So then we draw a dotted line to find the corresponding PWS, and that is P1HR. After we obtain P1HR, then we put in the formula of porosity, and we can get the porosity, and we also can get the permeability from the slope of the. This is the graph example.
Hello, my name is Arif, and I'm going to explain about case 2, which is about well is shut in after producing. Pressure behavior at observation well is given by PWS equal to Pi plus M log bracket Tp plus delta T over delta T. When plotting PWS versus Tp minus delta T over delta T on a semi-log graph, it yields a straight line portion of slope M, which may be used to calculate K and porosity, where P1HR is obtained from the semi-log straight line at dt equal to 1 hour. This is the graph.
Hello, my name is Zafri, and now let's look at analysis of the interference test using type curve matching. In type curve matching, we plotted dP versus T, which is the pressure differential against time on a log-log graph, and we match the field data or the plotted graph to the master curve. Then we pick a match point, and finally we calculate the K permeability and porosity of the reservoir using the following equations. As you can see, these are the formulas for permeability and porosity using the data gained from the type curve matching in the calculation. And the four data which are gained from the type curve matching are the PD, the delta P, T, and Td over R squared D. To make this clearer, it is better if we directly look at an example question and do it. In this question, the water was injected into a well during a 48 hours interference test, and an observation well is located 119 feet away from the active well, and the pressure response are observed. And here we have the data for the well and other formation properties, and these are the interference test data, which it consists of the time and the pressure at the observation well. So let's do this. Step 1, we plot the dp versus t on a log graph as explained earlier, and from the data which are given, this is what I got for my plot. Then for the second step, using the graph plotted from the previous step, I match it against the masked curve, and then we pick a match point, and from the match point we obtain the 4 values which are explained earlier, which are the pt, td, delta p, t, and td over r squared d. Those 4 values are obtained from the match point. And finally, using the 4 data which are obtained earlier, we calculate the permeability using this formula, and that's it. And that's all from us. Thank you.